from our observation that water can exist in three states of matter: solid as ice, liquid as the familiar water, and gas as water vapor. What happens inside the matter during this change of state? Or what happens to the particles of matter during changes of state? How does this change of state take place? We need answers to these questions, isn't it? Firstly, let's see the effect of change of temperature on states of matter. When a solid is heated, it changes into liquid, and when a liquid is heated, it changes into gas. So when a gas is cooled, what will happen? It will change back to liquid, and when a liquid is cooled, it will change back to solid. For example, if ice is heated, it changes into water. If water is heated, it changes into steam. So what happens the reverse way? If steam is cooled, it changes back to water, and if water is cooled, it changes back into ice. Now why does this happen this way? When a solid is heated, the particles begin to vibrate with greater speed and begin to move more freely. Then at a particular temperature, the solid melts and changes into liquid. The process of melting is known as fusion, and the amount of heat energy required to change 1 kilogram of a solid into liquid at atmospheric pressure at its melting point is called the latent heat of fusion. And the temperature at which solid changes its state to liquid at atmospheric pressure is called the melting point of that liquid. And the melting point of ice is 0 degrees Celsius or 273.15 Kelvin. When a liquid is heated, its particles begin to move even more faster, and then at a particular temperature, the liquid begins to boil and changes into gas, or what we call as the vapor. Boiling is a bulk phenomenon. When a liquid boils, the bulk of the liquid changes into vapor, and the amount of heat energy required to change 1 kilogram of a liquid into gas at atmospheric pressure at its boiling point is called the latent heat of vaporization. And the temperature at which a liquid starts boiling at its atmospheric pressure is known as its boiling point. And the boiling point of water is 100 degrees Celsius or 373.15 Kelvin. So we just saw that substances around us change state from solid to liquid and from liquid to gas on application of heat. But there are some that change directly from solid state to the gaseous state and vice versa without even changing into the liquid state. For example, if solid camphor or ammonium chloride is heated, it changes into vapor state. If the vapors are cooled, it changes back into the solid state. And such a change of state directly from the solid to the gas without changing into the liquid state or vice versa is called as sublimation. Now let's see the effect of change of pressure on states of matter. We have already seen that the difference in various states of matter is due to the difference in the distance between the constituent particles, right? So what will happen when we start putting pressure and compress a gas enclosed in a cylinder? Will the particles come closer? Do you think that increasing or decreasing the pressure can change the state of matter? Yes, it can. Applying pressure and reducing temperature can liquefy gases. Have you heard about solid carbon dioxide? It is stored under high pressure. Solid carbon dioxide gets converted directly to the gaseous state on decreasing of the pressure to 1 atmosphere without coming into the liquid state. And this is the reason why solid carbon dioxide is also called as dry ice. Thus, we can say that pressure and temperature determine the state of a substance, whether it will be a solid, liquid or a gas. Now, do we always need to heat or change the pressure for changing the state of matter? Can you quote some examples from your everyday life where change of state from liquid to vapor takes place without the liquid reaching the boiling point? That's also possible. Water, when left uncovered, slowly changes into vapor, and that's how wet clothes dry up, right? So what is actually happening to the water here? We know that particles of matter are always moving and are never at rest. At a given temperature, any gas, liquid or solid, there are particles with different amounts of kinetic energy. In the case of liquids, a small fraction of particles at the surface having higher kinetic energy is able to break away from the forces of attraction of other particles and gets converted into the vapor state, and this phenomenon of change of a liquid into vapors at any temperature below its boiling point is called as evaporation. Now, what are the factors that affect the rate of evaporation? The rate of evaporation depends upon surface area, temperature, humidity and the wind speed. You increase the surface area, the rate of evaporation increases. Increase in temperature increases the rate of evaporation again. Increase in humidity decreases the rate of evaporation, whereas increase in wind speed also increases the rate of evaporation. Did you know that evaporation causes cooling effect? When a liquid evaporates, the particles of the liquid absorb heat from the surroundings and evaporates. So the surroundings become cold. Example, people sprinkle water on the roof or on open ground because during evaporation, water absorbs the heat and thereby makes the hot surface cool. Similarly, during summer, we sweat more, right? That's because during evaporation, the sweat absorbs the heat from our body, making the body cool. Also, wearing cotton clothes in summer keeps us cool because cotton absorbs sweat, and when the sweat evaporates, it absorbs heat from our body, making the body cool. So to summarize, pressure and temperature determine the state of a substance, whether it will be a solid, liquid or a gas. And the interconversion of these states can happen through processes such as fusion, solidification, vaporization, condensation and sublimation.